This is Geometry, Unit 5. We're working on properties of rhombuses, rectangles, and squares. We've learned many of the properties of these shapes. Now we're going to look at how the diagonals are affecting the rhombus. If a parallelogram is a rhombus, or a parallelogram is a rhombus, if and only if the diagonals are perpendicular. So if you look over here, we have a parallelogram because we notice the arrows are on our shape. That shows that we have two sets of sides are parallel. The diagonals will always be perpendicular to each other. Any rhombus that we have here, the diagonals, this one that shoots across here, it's a little too long, but that's okay. And this one that shoots across here, it almost lines up perfect. They are going to be perpendicular no matter what shape the rhombus is in. Those diagonals are going to be perpendicular every time. They always form a right angle in the middle. So ABCD is a rhombus if we know the diagonals are perpendicular. If AC is perpendicular to BD. Another cool property about a rhombus is that the diagonals will bisect these opposite angles. We can prove that by looking at how the triangle that's formed by a diagonal is congruent on both sides. Therefore, the corresponding angles would be congruent. So this diagonal is going to come through here, and it's going to cut that angle exactly in half. That is not true about every rectangle. So if we come in here and we put a diagonal onto a rectangle, you'll see a big angle here and you'll see a small angle. That is not being bisected. But if we have a rhombus, that rhombus, the diagonal cuts this angle right in half, makes two congruent angles every time. ABCD is a rhombus if and only if AC bisects this big angle. So we're going to name it with three letters, BCD, and BAD. So the diagonal is going to bisect both of those angles. The other diagonal, BD, it's going to bisect both the big angles. So you go ahead now, write down the two angles that are going to be bisected by segment BD. I'll pause it, or you pause it, and come on back and we'll talk you through it. So segment BD is going to bisect the big angle here called ABC. It's also going to bisect the angle down here called ADC. So those are two properties about diagonals with a rhombus. Diagonals are going to be perpendicular, and diagonals are going to bisect the opposite angles. Diagonals also bisect each other, remember? Because it's a parallelogram, it's going to hold that same property. That's not any different. Diagonals do not have to be the same length in a rhombus. That was pretty clear from when we looked at this shape in the past, right? Diagonals are not the same length necessarily. Only if it's a special shape are they the same. But they always bisect each other, they are always perpendicular, and they always bisect opposite angles if you're a rhombus. Now we have another shape we're going to talk about, a rectangle. That's this guy. We have a rectangle. And in a rectangle, the diagonals are going to be the same length. They're going to bisect each other, but even better than that, they're still the same length. So whatever this half portion is going to be the same all the way around. Notice that the diagonals are not necessarily perpendicular. The closer a rectangle is to being a square would have diagonals congruent. So if you keep bringing this in, then the diagonals would be the same. They would form, diagonals would be perpendicular is what I'm supposed to be saying. The diagonals would be perpendicular if it was a square. They're only congruent. A parallelogram is a rectangle if and only if the diagonals are congruent. That's the one thing we know about the diagonals. Notice the diagonals are not bisecting the angle. They're not the same on both sides. This one's clearly bigger. We don't have a right angle here. They're just congruent. So AC, segment AC, is congruent to segment BD. All right, this shape here is going to go down to the next page. We don't use that shape here, even though we almost could. It says sketch a rectangle. So we want to make a four-sided figure that has perpendicular sides. And it's a parallelogram that's going to have two sets of opposite sides congruent, four right angles, diagonals that are congruent. It's going to have all the properties of a parallelogram. Opposite sides congruent, opposite angles congruent, consecutive angles supplementary. So what we're going to do is list everything we know about this rectangle. So one thing we know for sure, if this is a rectangle, what's the definition of a rectangle? Four right angles. That's definitely true about every rectangle. We have four right angles. No doubt about that. We know that the diagonals are congruent. That is true about every rectangle. Now, specifically a rectangle, we're kind of done. That's the most that we can say about a rectangle. We know that a rectangle is always a parallelogram. A rectangle is always a parallelogram. A parallelogram is not always a rectangle. So now, if a rectangle is a parallelogram, then a rectangle is going to have all the properties of a parallelogram. So start thinking about what those properties of a parallelogram are. See if you can write down the next few properties that are specific to parallelograms, that totally are true about a rectangle. All the properties of a parallelogram. If you have to look back at the previous pages of your notes, you could do that. But you go ahead and do that, pause the video, write those down, come back, and we'll discuss it. So to talk about some of our properties of parallelograms, we know we have two sets of parallel sides. That's kind of the definition of a parallelogram. That's going to be true about a rectangle. Two sets of congruent sides. That's true about every parallelogram, and that's obviously true about a rectangle. Opposite sides are congruent. We have opposite angles congruent. We have consecutive angles supplementary. That's also true about every rectangle. It's also true about every parallelogram. Here's a parallelogram. That shape there would be our parallelogram. Opposite angles are both congruent. Consecutive angles are supplementary. Opposite sides are congruent. Opposite sides are parallel. All those properties are true about every parallelogram and every rectangle. We're talking about rectangles right now. So those would be true about a rectangle. Are there any that we missed? That's a pretty good list of them. Let's take a look over here. The shape that was on the other side was a frame 20 by 16 was the frame. Okay, a frame is going to be a rectangle. That's what we would expect. Given the measurements in the diagram, can you assume that this is a rectangle? If you know you have two sides that are 20 and two sides that are 16, do you know you made a rectangle? What we see there are opposite sides being congruent. If you know opposite sides are congruent, like this shape, do you know you have a rectangle? Just because opposite sides are congruent does not mean you have the sides perpendicular. Just because the opposite sides are the same does not make the sides perpendicular. So I would call this no. Just because we have 20s and 16s does not make this a rectangle. just because opposite sides are congruent, doesn't mean sides are perpendicular. We don't know we have perpendicular sides just because opposite sides are the same length. Now, if we measure the diagonals of the frame, the diagonals are 25.6. And that's one direction, and it says plural here, diagonals. So the other diagonal is this guy. That would be 25.6. So if the diagonals are both 25.6, would that be enough to prove the shape? And that would be true. Every rectangle has diagonals that are congruent. That's a little bit long, but these diagonals are going to be the same length from corner to corner, is going to be the same length in a rectangle. If it was a parallelogram, that would not necessarily be true. You see that the diagonal is way too long on this one, but it's way too short on that one. It's got to be a rectangle for those diagonals to line up. My diagonals are still a teeny bit long, but all right. What can you conclude about the shape? If a parallelogram has congruent diagonals, then it is a rectangle. It's got to be a parallelogram. And if the diagonals are congruent, then it's a rectangle. Suppose the diagonals in the frame are not congruent. Could the frame be a rectangle? And that was no. The diagonals of a rectangle must always be congruent. And that's what we were talking about here. The diagonals are going to be the same length in a rectangle. Okay, here's our last example. The diagonals of our rhombus intersect at point V. Given that the measure of angle XZY is 34 and WV is 7, find these other measurements. Well, let's first focus just on our figure. What do we know about a rhombus? We know that opposite sides are congruent. We know that all the sides are congruent, in fact. we know that the diagonals bisect each other. So the diagonals are, if it's 7 on one side, it has to be 7 on the other. We know that the diagonals are going to bisect this angle. This angle is going to be 68 degrees. So if that's 34, this has to be 34. That makes 68. And that's going to be the same on the other side. 34 and 34. That's 68 degrees. Consecutive angles are going to have to be supplementary. So that means this has to be 112 degrees. And half of 112 is 56. So if those are 56, these are 56. And of course, diagonals are perpendicular. That's most everything we know about a rhombus. Without doing other types of calculations, we don't know the length of this diagonal. So we can't talk about that. But let's come on and see if we can finish out these last few examples. WZV. This big angle is going to be twice the 34. It's going to be 68 degrees. Angle XYZ, we found out, was going to be 56. It's going to be half of the supplement to 68. 56. WY is the total length of the diagonal. If half of it is 7, then double that is going to be 14. And then XY is the length of the consecutive sides. And in a rhombus, they're all the same. So that's everything that we know about a rhombus. Good job, everybody. Apparently, our calculation here was XYZ, not XYV. So we're not just looking for 56, we're looking for 112, which is the supplement of 68.